For problem number 13, we are noticing we have to graph and then define some characteristics about the function -3 plus the square root of x plus 2. We should notice that this function here is just a transformation of our parent function y equals the square root of x, which we should know that the shape of the graph is we have a starting point here at 0, 0, and the graph moves up and over like that, and that's based on well, when you pick values for x, plug in values for x, you have an input of 0, square root of 0 is 0, input of 1, square root of 1 is 1, input of 4, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and on and on. So notice that the x values get really, really big, where the y values they get bigger, but they don't get bigger as fast as the x values do. That's why it has a curve like that, and that's the main thing that you should understand. Why does the graph look like that? And then we have a limited domain on these, because notice that when we have the square root, we just are not allowed to have any negatives under the square root. That's why we see the graph have a starting point, unlike some graphs that have a domain of all real numbers. So anyway, the other transformations, if we have a minus sign on the outside, we reflect the original graph about the x-axis. The minus sign is on the inside, we reflect the graph, original parent function about the y-axis. If we happen to have a minus sign outside and inside, then we would reflect both about the y-axis and then the x-axis. So you get the reflections here, but in this case, when we define h of x, we like to write it in terms of a times the square root of x minus h and then plus k. We like to see it like that, because then we know that whatever's being subtracted from the x is our h, whatever's being added to the outside is our k. Our h goes left and right. There's a quick review of every function that we've studied this year. And the k is the value that goes up and down. When you see a minus sign inside, so instead of just being an x, we have an x minus a number, then that means we're going to go to the right. If we have an x plus a number, that means we go to the left, because when we have a minus sign, the h is positive. H is positive, we go to the right. The k value is just, we go up if it's positive, we go down if it's negative. And then the a value, that's what we already talked about. If the a value is negative, then we reflect the graph about the x-axis. If a is a number that's either greater than 1 or less than -1, so the absolute value is greater than 1, that means it's a vertical stretch. If we get a number here between 0 and 1, we have a vertical compression. But the bottom line is, we have this function here, h of x, and I want to rewrite it so it makes it a little bit more visually pleasing. Is radical x plus 2 and then minus 3. So sometimes students get confused when they see this -3 out in the front. They think they have to flip it over the x-axis. Well, that's not the case. That's the k value. And the h value is -2. So we have a k value of -3 and h value of -2. And it's figuring out the domain. We can figure out the domain after we graph it. But the bottom line is, we take this graph of y equals radical x and we move it to the left 2 and down 3. So left 2 and down 1, 2, 3. So that's how we find the starting point. And since we didn't reflect the graph about the x or y axis, it's going to look just like this one. And so we go up and over, and for the purposes of getting the graph to look right, just find the starting point, figure out which one of these four the graph's going to look like, and then just draw it. And just make sure you draw it, and make sure you're a little bit careful. Don't just be haphazard about this. Don't go up and down. Don't go kind of way up there. Just kind of a nice normal kind of curve that goes up 1 and over 1 first, and then just kind of follow that path. And make sure that if it's going up, meaning the function is increasing, make sure that you keep it increasing. Don't come back down. I see sometimes students will come back down and then they don't get the idea, not showing me they understand the idea that it's going to be continually increasing here. So therefore, once we have the graph, we have our starting point of -2, -3, then we can come up with the domain. The domain is starting here at -2, and all the way to infinity, including -2, and all the way to the right. The range always is the lowest y to the highest y. The lowest y value is -3, and the highest y, there's no highest y, it just keeps going on forever, so we say that's infinity. Increasing all the way on what interval? Increasing on, so this is the x values. So we have x values and not y values there, x values. So the function is increasing all the way from -2 to infinity over the entire domain. And we don't worry about endpoints when we're dealing with increasing and decreasing, so that's why we don't have a bracket there. If you put a bracket there, it's still going to be marked right, but I don't need one. So if it's always increasing over its entire domain, then it's never decreasing. The x-intercept, that's the one we'll leave to the very end because that's the most difficult one to find. Maximum value, we have no maximum value. We'll leave the y-intercept for the second to the last. Minimum value, it's the lowest y value on the graph, so that's our -3. Minimum value, it's not an ordered pair. A value is the y coordinate. 1-to-1, this is a yes. This is 1-to-1. So for every x there's one y, for every y there's one x, and you can tell that by the horizontal line test, that 1-to-1. The y-intercept is when we just let x equal 0. So where could we do that work right here? I'm going to do that work right here. So h of 0, if x is equal to 0, is the square root of 0 plus 2 minus 3. So we have the square root of 2 minus 3, and we can't simplify that at all. So when x is 0, we have, again, square root of 2 minus 3. Keep that minus 3 on the outside of the radical symbol. And finally, that's the y-intercept. Finally, for the x-intercept, we want to set this function equal to 0. Let h of x equal 0. So if h of x is equal to 0, we have 0 equals the square root of x plus 2 all minus 3. To solve this, we've been solving these, so now we should be pretty comfortable doing this. We want to isolate the radical, and by isolating the radical, I mean move any numbers to the other side that are on the same side of the radical. That's isolating the radical. So we add 3 to both sides because we have a -3 over here. If we had a +3, then we'd subtract 3. We have to do the opposite. Opposite means that those two add up to 0. 0 plus 3 is 3 equals the square root of x plus 2. Now we want to look to get the x by itself, so we want to isolate the x. Well, how do we do that? We have to get rid of the radical. How do we undo radical? We square both sides. And when we square both sides, we see the left side is 3 squared is 9. The right side is x plus 2. Squaring undoes square root. And then we subtract 2 from both sides. And after subtracting 2 from both sides, we see clearly that x is equal to 7. That's our x-intercept. And that's consistent with the way we drew our graph. We could see it's increasing. When it gets to 7, it's going to cross the x-axis. And so there we go. We have 7, 0.